Hello everyone, and welcome to our channel Consumer Times. Today's topic we will talk about reducing carbon footprint in marine transport. Sustainable solutions for a greener future. Please like, share, comment and do not forget to subscribe our channel by clicking subscribe button to motivate us. Reducing the carbon footprint of marine transport is crucial in the fight against climate change. As one of the primary modes of global trade, shipping moves more than 80% of the world's goods, making it a significant contributor to greenhouse gas (GHG) emissions. While marine transport is more efficient than road or air transport in terms of emissions per ton kilometer, the sheer volume of goods shipped across oceans makes its overall environmental impact considerable. The International Maritime Organization (IMO) has estimated that the shipping industry accounts for nearly 3% of global CO2 emissions. If left unchecked, these emissions could rise significantly by 2050, further accelerating global warming. Addressing this challenge requires concerted efforts from governments, international organizations, the shipping industry, and consumers. Here's a detailed look at the strategies to reduce the carbon footprint from marine transport. The most direct approach to cutting emissions from shipping is improving fuel efficiency and adopting cleaner fuels. Traditionally, most ships have been powered by heavy fuel oil, which is highly polluting. Transitioning to cleaner fuels, such as liquefied natural gas, LNG, biofuels, and even hydrogen, can significantly reduce emissions of CO2, sulfur oxides, SOx, and nitrogen oxides, NOx. LNG is already being used by some ships as a bridge fuel, as it emits fewer pollutants compared to traditional fuels. Hydrogen, especially green hydrogen produced from renewable energy, holds long-term promise as a zero-emission fuel. Ammonia, another zero-carbon fuel option, is gaining attention as it can be synthesized using green hydrogen. However, both hydrogen and ammonia require further technological and infrastructural developments to become viable options on a large scale. Improving the design of ships can greatly reduce their fuel consumption and emissions. Modern hull designs that reduce water resistance, along with optimized propeller and rudder designs, can lead to significant energy savings. For example, bulbous bows, an extension of the hull just below the waterline, reduce drag and improve fuel efficiency for large ships. Additionally, integrating energy-saving technologies like air lubrication systems, which reduce friction between the ship's hull and water by creating a layer of air bubbles, or rotor sails, which harness wind power, can make ships more energy efficient. Retrofitting older ships with these technologies and upgrading engines to more efficient models can also help the current fleet reduce its carbon footprint. Ships can be equipped with waste heat recovery systems, which capture the energy from exhaust gases to generate additional power, further cutting fuel consumption. Operational measures, such as speed optimization, route planning, and just-in-time arrivals, can significantly lower emissions. Reducing a ship's speed, commonly referred to as slow steaming, can lead to substantial fuel savings and emission reductions. A slight reduction in speed can reduce fuel consumption exponentially, as the energy required to move a ship increases with the cube of its speed. Route optimization through advanced weather routing and satellite systems can also minimize fuel consumption by avoiding adverse weather and currents, while just-in-time operations ensure ships arrive at ports exactly when needed, reducing time spent idling and burning fuel. Renewable energy sources such as wind and solar power can play a role in reducing the carbon footprint of marine transport. For example, wind-assisted propulsion systems, like Flettner rotors and kites, can reduce fuel consumption by supplementing traditional engines with wind power. Solar panels can be installed on the decks of ships to generate electricity for auxiliary systems, reducing the load on the main engine and, consequently, fuel consumption. In addition, research is being conducted on battery electric ships and hybrid systems, particularly for short-distance travel such as ferries and coastal shipping. Electric propulsion powered by renewable energy could dramatically cut emissions in these sectors, though energy storage technology must advance further to be viable for larger vessels and long-distance travel. The carbon footprint of marine transport is not limited to the ships themselves. port infrastructure and operations also contribute significantly to emissions. Ports can reduce their carbon footprint by providing onshore power supply, also known as cold ironing, so that ships can turn off their engines while docked and rely on cleaner electricity from the grid. In some cases, this electricity can come from renewable sources, such as wind or solar power, further reducing the carbon footprint. Automation and electrification of port equipment, such as cranes and trucks, can also help lower emissions. Additionally, enhancing the efficiency of port operations, reducing the time ships spend waiting to dock or load, unload, can minimize fuel use and emissions associated with idle ships. Regulation plays a critical role in reducing the carbon footprint of marine transport. The IMO has set a goal to cut the shipping industry's total GHG emissions by at least 50% by 2050 compared to 2008 levels, with the ultimate aim of decarbonizing the sector entirely. This target is ambitious and will require significant technological innovation, investment, and international cooperation. Countries and regions are also implementing their own measures to curb emissions. For example, the European Union is including maritime emissions in its emissions trading system, (ETS), which will require shipping companies to buy permits for their CO2 emissions, incentivizing the adoption of cleaner technologies and fuels. Financial incentives, such as subsidies or tax breaks for cleaner ships, and penalties for polluting ships, can further accelerate the shift toward greener maritime transport. The challenge of decarbonizing marine transport is too large for any single entity to tackle alone. Collaboration among ship owners, cargo owners, governments, and technology providers is essential. For example, shipping alliances and major industry players can work together to develop and share best practices, scale up investments in green technologies, and promote regulatory frameworks that incentivize sustainability. Moreover, investments in research and development are crucial. Innovations in fuel cells, energy storage, and carbon capture for ships can play a key role in reducing emissions. Public-private partnerships and international cooperation will be critical in advancing these technologies and making them commercially viable. Finally, consumers and businesses can play a role in reducing the carbon footprint of marine transport. Increasing demand for greener shipping options can push the industry to adopt cleaner technologies faster. Large companies, particularly those with substantial supply chains, can prioritize shipping partners committed to reducing emissions and encourage transparency in carbon reporting. By opting for carbon neutral or carbon offset shipping services, consumers can help support sustainability initiatives. Companies like Amazon, IKEA, and Unilever have already committed to reducing emissions from their supply chains, setting an example for others to follow. Reducing the carbon footprint of marine transport requires a multifaceted approach, combining technological innovation, regulatory action, operational efficiency, and global collaboration. Cleaner fuels, better ship design, alternative energy sources, and efficient port operations can all contribute to cutting emissions. As the world moves toward a greener future, it is vital that the shipping industry plays its part in mitigating climate change by adopting sustainable practices and reducing its carbon footprint. Thanks a lot for joining us today. If you enjoyed this video, please give it a thumbs up. Do not forget to comment, which are very valuable to us. Please like, please do not forget press subscribe button to motivate us.